For decades, this canyon cut entire communities off from the rest of China. Crossing it could take hours, and sometimes it was not possible at all. Narrow mountain roads twisted along steep cliffs. Weather could shut them down without warning. What should have been short trips often turned into dangerous journeys. The solution was not a tunnel or a longer road. It was a bridge hanging 625 meters above the valley, built in one of the most unstable landscapes on Earth. Please take a moment to subscribe and like the video. It really helps the channel. This structure looks like it should not exist. It hangs so high above the Huajiang Canyon that standing on it feels like climbing China's tallest skyscraper and stepping off the roof. Wind tears through the valley below. The mountains slowly shift over time. The ground itself is unstable, and yet engineers built a bridge here anyway. Not just a tall bridge, but one of the most complex ever attempted. The bridge sits in Guizhou province, one of China's most extreme regions. More than 90% of the land is mountainous, so steep and uneven that locals joke there is not even 3 feet of level ground anywhere. From above, the landscape looks stunning. Deep valleys and sharp peaks stretch in every direction, earning Guizhou the nickname the Switzerland of China. But that beauty came with a cost. For decades, the terrain made travel slow, risky, and unreliable. Entire towns remained isolated simply because there was no safe way to cross the mountains. By the early 2000s, this isolation had become a national problem. Around 2012, China launched one of the largest inland infrastructure programs in modern history. Hundreds of billions of dollars were invested in poorer interior regions with one clear goal: connect them. Airports were built. High-speed rail lines followed. Expressways began cutting through landscapes once thought impossible to cross. In Guizhou alone, this effort led to the construction of more than 32,000 bridges. Each one shortened travel times, opened access to markets, and tied remote communities into the national economy. Nowhere showed the need for this better than the Huajiang Canyon. Before the bridge, crossing the valley meant driving narrow mountain roads that could take up to 2 hours. Hairpin bends, steep drops, and sudden weather changes made every trip unpredictable. Engineers knew the only real solution was to go straight across the canyon. That idea became part of the S57 Expressway, a 150-kilometer highway with 14 interchanges that cuts directly through Guizhou's mountains. To build it, crews blasted through solid rock, drilled deep into cliffs, and carved a massive V-shaped corridor straight through a mountain range. At the center of that expressway stands the Huajiang Bridge. It stretches 2,890 meters from end to end, with a main span of 1,420 meters suspended above the Beipan River. When it opened earlier this year, it officially became the highest bridge on Earth, pushing bridge height to levels never used before. Spanning a canyon this deep forced engineers to make difficult design choices early on. Cable-stayed designs were considered, but the extreme height and long span pushed them beyond safe limits. A traditional suspension bridge offered flexibility, but anchoring massive cables in unstable terrain carried serious risks. The final solution was a steel truss suspension bridge. This design had proven reliable in mountainous regions, where solid rock could anchor enormous forces. Steel trusses added stiffness, while suspension cables carried the weight across the vast gap. Before construction even began, survey teams studied up to 10 kilometers of canyon in both directions. They examined rock strength, fault lines, wind behavior, and tower placement options. Every constraint shaped the final design. Canyon width limited where towers could stand. Foundation depth controlled their height. Extreme elevation introduced forces rarely faced in bridge construction. The result was not just a solution, but an unexpected world record layered on top of the first. Nothing about this bridge could be built using normal methods. Engineers digitally assembled the entire structure before a single steel section arrived on site. The bridge consists of 93 massive steel truss segments, weighing a combined 22,000 tons. For comparison, the Eiffel Tower contains about 7,300 tons of steel. Huajiang uses roughly 3 times that amount, suspended over open air. Traditional cranes were useless here. Even the tallest crane in the world stands about 250 meters high. Stacking 3 of them would still not reach the canyon floor. Instead, engineers built a cable crane system that worked like a suspended railway. Steel components moved along overhead, cables stretched across the valley. Construction began at the center of the span and moved outward in perfect balance, keeping the structure stable at every stage. At this height, precision was critical. Steel segments were positioned using the Beidou navigation satellite system, China's version of GPS. Alignment errors were measured in millimeters. One small mistake could have sent thousands of tons of steel swinging uncontrollably above the canyon. Every movement was planned, checked, and executed with extreme care. The canyon itself created another challenge. Its walls slope unevenly, making identical foundations impossible. Lessons from earlier failures, including the collapse of the Huajiang Bridge, pushed engineers to adapt instead of forcing symmetry. The North Tower rises 262 meters, while the South Tower stands at 205 meters. Their anchoring systems differ in depth and design, each matched to the local geology. The bridge is asymmetrical because it has to be. This region is also seismically active. To survive earthquakes, the bridge needed to move without breaking. Engineers treated it like a giant pendulum, free to sway within controlled limits. Shock-absorbing dampers allow the structure to respond to earthquakes and temperature changes without sending damaging forces into the towers or cables. Here, flexibility keeps the bridge safe. Wind posed one of the greatest threats. The canyon squeezes air through a narrow space, creating powerful gusts similar to those produced by high-speed trains. Engineers tested scale models in wind tunnels and ran detailed simulations to predict real-world behavior. Doppler LiDAR systems now track wind movement in 3 dimensions, turning invisible forces into visible data in real time. Once traffic began flowing, monitoring did not stop. Fiber optic sensors built into the bridge constantly measure tension, vibration, and load changes. The suspension cables use pre-formed parallel wire strands, the most critical parts of the entire structure. Any unusual movement triggers immediate alerts, allowing engineers to respond long before problems appear. Maintaining the bridge requires working at heights once considered impossible. Catwalks run above the roadway, where crews operate hundreds of meters above the canyon floor. For most of history, bridge engineering was limited by river height. Here, that limit no longer exists. Human access has moved into the sky. The entire project cost up to $300 million and took just 3.5 years to complete. That speed reflects a larger pattern. China leads the world in high-speed rail length, bridge construction, and dam building. Huajiang is not an exception. It is the result of a system designed to build at scale. This bridge is part of something bigger. It supports poverty reduction by linking isolated regions to major economic centers. It also fits within the broader Belt and Road Initiative, showing China's engineering strength on a global stage. But beyond economics and strategy, Huajiang is also being reimagined in a very different way. The bridge is being developed as a destination. Plans include an 800-meter glass elevator rising through the canyon, a 2-story cafe built into one of the bridge towers, and a glass walkway beneath the road deck. An artificial waterfall and extreme sports attractions, including high-altitude bungee jumping, are also proposed. The Huajiang Bridge stands as an engineering achievement, an economic link, and a future tourist landmark combined into one structure. It shows how modern infrastructure no longer works around the landscape, but reshapes it entirely. Bridges like this are no longer just ways to get across. They are destinations in their own right, pushing the limits of what engineering can achieve. Thanks for watching Unthinkable Build. We'll see you in the next one.